Laplace transforms to solve the following initial value problem. So we got a second order differential equation and two initial values. So we take Laplace on this differential equation. Okay, just take Laplace. That means Laplace of y double prime plus Laplace of 4y. That is same as 4 Laplace of y equals Laplace of 3 sine t. That is same as 3 Laplace of sine t. Okay. Then from the table, look at the formula. Laplace of y double prime is s square uppercase y, or Laplace of y, minus s y0 minus y prime 0. Okay, that is coming from the Laplace transform table. Laplace of y double prime plus 4 Laplace of y, just as it is because we don't know anything, equals 3 times Laplace of sine t. Again from the Laplace transform table, sine t is 1 over s square plus 1. Okay. Now let's use these two initial values. Y at 0 is 1. So this value is 1. And y prime at 0 is negative 1. This is negative 1. And as usual, we can factor Laplace of y from both terms. I mean, in this case, two terms. So Laplace of y, that leaves s squared plus 4. And these are other terms without Laplace of y. So negative s minus negative 1 is plus 1 equals, this is 3 over s squared plus 1. Okay. Now we want to isolate Laplace of y, then take inverse Laplace to recover y. Solving means finding y as a function of t. Okay. Move these two terms to the other side. So Laplace of y s squared plus 4 is equal to 3 over s squared plus 1 negative positive s minus 1. Okay. Now we want to divide, there are 3 terms, by this factor s squared plus 1. So Laplace of y, here this will be complicated looking, s squared plus 1, and we are dividing by s squared plus 4 plus s over this one. Okay, dividing means dividing all terms on the right side, minus 1 over s squared plus 4. Okay, now we change this calculus problem into an algebraic one. Now we take the inverse Laplace of both sides, then we get y of t equals inverse Laplace of this junk, which takes a lot of time here, 3 over this one plus inverse Laplace of this, but this is from table. Look at that, this is from table. This is Laplace of cosine 2t. So inverse Laplace of this is just cosine of 2t. And how about here? We know that 2 over s squared plus 2 squared, that's Laplace of sine 2t. Okay. So the 2 missing, but we can always multiply by 2 and divide by 2. So this is negative 1/2, negative 1/2, and 2 over s squared plus 4, just from here, sine 2t. Okay. Now we need to work here. We need to find inverse Laplace of this complex fraction. Now whenever we have a complex fraction, because we have a lot of things on the bottom. We do the partial fraction decomposition. That means write this fraction as a sum of simpler fractions. Then we take inverse Laplace. So let's do over here. So this is 3 over s squared plus 1 plus 4. Okay, this complex fraction. This is same as s squared plus 1 s squared plus 4. Okay, this is degree 2, so we write as plus b. But if we look at closely here, there are no s terms. Okay, so we can just write a constant. This is good. In that case, a will be 0, but there are no terms containing s, so we can simply write just a constant. I want to take a and b. In fact, this is as plus b and cs plus d, something you can do in that way, but this works because we don't have any terms containing s. Okay, we let this complex fraction being sum of these two simpler fractions, then we multiply through by this common denominator. So this is 3 equals a times s squared plus 4 plus b times s squared plus 1. Okay, now we are trying to determine the values of a and b. Take s equals something, I don't know. Okay, nothing makes this term 0, so let's choose easy s values. I don't know, 0. Then we get 3 equals 0 4a plus b. All right, there is, yeah. So we have an equation, 3 equals 4a plus b, or this is same as b equals 3 minus 4a. So we can use this later. So now we can take anything. Let's take easiest on there, maybe 1. So 3 equals 1 square 1 plus 4 5a plus 1 square 1 plus 1 2b. But b is found here. B is 3 minus 4a. 2 times b. So 2 times 3 is 6 minus 2 times 4 8a. 3 minus 6 negative 3. 5a minus 8a negative 3a divided by negative 3. So a is in fact 1. And plug in here. B is 3 minus 4 negative 1. Okay. Now we come back here. So this is inverse Laplace of this complex fraction is a over that. A means 1 over s squared plus 1 plus b over, b is negative 1, so I can write negative 1 over s squared plus 4. And these two terms are already done. Cosine 2t minus 1/2 sine 2t. Now let's find inverse Laplace. Same like here. Inverse Laplace of 1 over s squared plus 1. That's sine t. Sine 1t. 1 sine t. Minus 1 over s squared plus 4. Oh, okay, it was here. Okay. Again sine t, but there's a 4 means we need 2 here. So we can multiply by 2. And to balance, we need to divide by 2 as well. So negative 1/2 sine 2t plus here is cosine 2t minus 1/2 sine 2t. So this is the final answer. Y equals, in fact, negative 1/2 sine 2t, negative 1/2 sine 2t. We can combine negative 1/2. Negative 1/2 means just 1. So this is sine t. From these two terms, negative 1 copy of sine 2t plus cosine 2t. That's y equals final